Hi, folks.
Hey guys,
Hi.
pay attention now.
So we're just
Can you
starting
hear
a
us?
little bit early, and we are going to. What are we going to do? We're just doing some testing right now because this is the first time we've gone live and actually done something.
Yeah, just wanted to make sure that this technology works. We did another one of these about an hour and a half ago, and we had some technical issues, but I think
Different
this is
technology, we
different
should say.
technology though. So this looks good so far. Should we introduce ourselves?
Yeah, that would be a good idea. I'm just going to go live on the Facebook live stream as well. Feeling a little bit dirty with Facebook. Yes, go live. Arduino here and a done.
Grab that.
Start live video. The last time I did this, I'm gonna steal your stand.
Yeah.
Oh.
You need a stand, right?
Actually, will this work now? That works.
Do you want? How about you put it here?
I'll let you.
On the book here. Since your camera is
I
up.
think I have to be.
Oh.
That's okay. No, it's like, oh, no, it wants you to be portrait.
Really?
Yeah.
That's
Forever teaching our children how not to hold a camera properly.
Maybe this can help.
We're not budget at all. This is great.
How about that? We'll have to be really close together.
Yeah, hey, Peter. Maybe I will ditch the last minute
Can you do it like that?
idea. Yeah, why not? Get to look very chummy.
Sorry about this.
That's okay. I just thought, why not stream out of Facebook, because
It's all live.
some people are still using it, right?
So it's pretty much 11 o'clock. Would you like to start?
Yes. So who are you?
So
Big
I'd like to say good morning to everyone who's taken a bit of time to join us in this special Adreno Day.
Thanks for showing up on a Saturday.
Yeah. So I'd like to introduce myself. I'm Peter Delmaris. My company is called Tech Explorations, and we build and create educational products on the Arduino, the Raspberry Pi, and a few other things like KiCad, for example. We also have courses on projects. The one that I'm working on now, and I'm finishing and I'm about to finish and publish. It's really a hobby. I just built this open source drone. It's using state-of-the-art electronics and flight controllers and lots of other gadgets here. But anyway, this is an example of some of the things that we do at Tech Explorations. Marcus, over to you.
Peter is very modest. The thing is, he knows a lot about Arduino, and we're going to totally get everything out of his brain that we can. So you guys know who I am. I run.
Sorry about that.
Well, I am at Little Bird, and I think most, or maybe we'll. Okay, that works too. Marcus from Little Bird. We sell Arduino stuff. We were like the first people to sell Arduino in Australia. When my dear lecturer said, Marcus, you're entrepreneurial, you should sell Arduino. We can't buy them in Australia. And I had no interest in doing that at the time, but I wanted good marks.
When was that?
That was 12 years ago. And one thing led to another, and here we have Little Bird with 25,000 products, lots of Arduino, Raspberry Pi, hobbyist stuff, STEM stuff. So that's how we got into it, and I think we've been teaching Arduino workshops for more than 10 years now, which is making me feel old. They've already going grey. Yeah. So
just wanted to mention that I also have a book. So I wrote this book last year because one of my passions is in education. Like I do consider myself as a maker, but I predominantly consider myself as an educator. So especially following or learning or taking example from the Maker movement and the way that education takes place in that movement, the people that are part of it, prompted me to write a book about it. This is Leo, by the way. He's my son, and we homeschool our kids. And the reason I'm saying that is we try to apply as much as we can out of what Maker education and the Maker movement is all about. So learning by doing, especially like everything that we teach as much as possible, we try to apply practically. There's some things that we can apply, like we can't do a practical experiment on how to do atom fusion, for example, or fission, even worse.
Some just not trying hard enough,
we
Peter,
keep
really.
it on paper, but anything that can be done practically, we try to do it practically. So what started this webinar about?
So this is a Q&A because to celebrate or mark Arduino Day, we're going to take your Arduino questions. Now you guys can chat with us in the system, and especially the guys in the GoToMeeting. If you're looking through the Facebook group, you can scroll down on the Little Bird Facebook page and click the link to take you to the webinar as well. So you can ask questions on the Facebook group. You can ask questions on the GoToWebinar software. I can see one question in there, which is more of a statement. Seems to work, full stop. So that's a good sign of things working.
So far, so good.
So far, so good. So let's jump in and
Marcus, just one
yeah,
thing.
go for it.
Are we recording at the moment? Because we'd like to record this.
Let's go scroll up dashboard, maybe.
Yeah, we'd like to record this so that we can post it somewhere and you can revisit it.
I think this session is being recorded.
Oh, yes. Okay.
There you go.
So everything you said will be recorded.
All types.
Marcus, especially for you.
So we have
be careful what you say.
One other person here today who we've totally neglected to introduce. Who do we have?
Hi, so I'm Emily. I'm a technology teacher at Broughton Anglican College in Campbelltown. Yeah, I don't know what else to say. I teach textiles, trained to teach computing as well.
With e-textiles, so things like the lily pad Arduino and the Flora, another wearable e-textile type of Arduino.
Emily, would you like to take a minute to tell us what e-textiles is and why should people, especially in education, be interested in it?
So one of, I guess, the more recent reasons why people in technology should be interested in it is in New South Wales we have a new syllabus for technology mandatory, which is our Year 7 and 8 technology course. And that mandates that we do 50 hours of digital technologies over the course of Year 7 and 8. One of the ways that can be done is integrated into other areas. So one of the ways a lot of textiles teachers are going at the moment, including myself, is then teaching ourselves how we can integrate e-textiles to cover that digital technology as part of the syllabus, as well as also, I guess, a way to keep our subject alive as well and relevant, because without that, it's in a lot of schools, it is dying a little bit, textiles. Yeah. So it's also to do with textiles innovation and stuff at the moment too. That's a big area of growth at the moment. So it's a lot of, at the moment, I guess, teachers upskilling themselves in order to be able to show this to our students as well.
Okay, awesome.
Great. So any questions about e-textiles, technologies, methodologies for the classroom resources? Emily is the person to ask.
So we've got our list of questions from people who've already submitted questions via email, but of course, feel free to submit questions in the system.
Marcus, how do people submit a question Did you talk about that?
On the right-hand side of your web browser, you should see a area to submit questions. And I see Steve has already done so. What, in your opinion, is the best way to hook sensors together with in textiles? So that's a great question to lead off with. So Emily, do you want to take that one?
The way I've done it in a project I've been doing lately is using conductive thread. It's flexible. It's pretty easy to sew with. It does have a slight learning curve to sew with, but it is pretty simple to sew with. Goes into the fabric really well. Handles being handled a lot really easily. That's the way I've been doing it lately.
What kind of sensors can you use, or typically people use in e-textiles?
One I've been experimenting with a bit lately is capacitive sensors, so using conductive fabric in order to make it a sensor. That's something I've been going with lately. I'm not sure what other people out there are using as well. I know there's all sorts of different ways people are doing it. That's why I've been trying lately.
So a bit of conductive thread, a high ohm resistor.
Just as an aside, since we're talking about sensors in textiles, I was reading in the New Scientist yesterday that there's a company in the UK that is building a hollow suit. So that the particular suit contains about 300 sensors integrated in it. And as you're playing, say, a virtual reality game, it uses electrodes to zap you on the muscles. So it actually produces muscle movement, and the perception from the user is that is like something hits you, like a bullet hits you, like if you're playing the kind of game. And then, but the same sensor also has the ability to measure heart rate. So the game knows based on that whether you're scared or stressed and things like that. The guy that is designing it says that he's wearing the same suit in long haul flights, because through those sensors and devices in the suit, he actually gets his muscles to exercise as he's sitting, so he avoids the problems of long flights.
Deep vein thrombosis and all that, yeah.
And that's once that hits the market, it's going to be about $1,000 to purchase. So
does he fly economy?
I'm just saying,
through security.
Yeah, but it's going to get a whole more interesting. Yes. And that is an example of what you can do at a larger scale with e-textiles, right? Yes. It's an example of high density e-textile application.
Absolutely.
So, right.
We should probably.
Thank you, Steve.
Well, there's a question in there that we've received. What is Arduino? I feel like we might be putting the horse before the cart by not answering this question. So, Peter, what is Arduino?
So the Arduino is not a thing. It's not a program. It's a platform, right? There are specific items in this platform, such as the Arduino Uno, that everybody usually uses as the first example of what this Arduino platform looks like. So the Arduino Uno is just a small board that contains a bunch of components on it. The main component being a microcontroller, which is, think of it as a small computer. So the idea with that small computer is that you can write a small program that can control external hardware, and that's why it's so useful. First of all, as part of the platform, you also get a programming language, and part of that language also includes things like libraries, which is pre-written software that then we can use to create programs that through the Arduino control devices such as motors and LEDs and sensors, without us having to write the low-level code, which is where most people are having trouble with, because the lower you go to the hardware,
but you can if you want to.
You can, yeah. So the Arduino is just a platform that makes working with hardware the easiest it's ever been, right? And that's why it's so popular. And especially in education, you can use the Arduino to learn programming, electronics, art. It takes it gives you access to so many things that you can learn that it's hard to find any other platform that can actually achieve that extended context of things that you can do with.
Yeah, I think the biggest thing that Arduino does is removes the need to do the memory management side of programming. So what they've done is they've taken C++, they've taken the hard edges, the sharp corners off it, and made it easy for artists and designers, and ultimately it became hobbyists as well, to go and build interactive systems for physical computing. So I guess the next question we should answer is, what can I do with an Arduino?
The question is, what can't you do?
Pretty much.
With the Arduino. So you saw my quadcopter. The previous version of that quadcopter was running on a chip that you'll find on an Arduino Mega. which is the bigger brother of the Arduino Uno. So that same technology that we use to turn LEDs on and off, we can use to fly a drone and do all sorts of interesting things like acrobatics, for example. You can write code, or you can write code that controls robots through motor controllers. LED light displays music, you can play music. You can learn programming. You can use the Arduino as a basis of Internet of Things projects. So think of an agricultural project where you have a bunch of Arduinos working together to do things like measure the salinity and moisture in soil, and then turn on a watering system automatically if the sensor's values come back within certain parameters. So, like, I don't know, it's hard for me to think of what Arduino perhaps can't do.
Awesome. So the Arduino is just like the Raspberry Pi, right?
No.
Why not?
Okay, so the Raspberry Pi is a full computer, right? So the biggest difference between the Arduino and the Raspberry Pi is the Raspberry Pi is really a miniature computer in the sense of the computer that we're using right now to do this broadcast, which contains peripherals such as storage devices, large storage devices, cameras integrated, USB devices that allow us to connect peripherals, large permanent storage such as hard disks and SSDs, embedded communications peripherals as well, graphics, a screen connected to it. So that's what the Raspberry Pi is in reality. It's got an operating system, which is a big difference between the Raspberry Pi and an Arduino. The Arduino doesn't have almost everything of what I mentioned interlisted above that, what a normal computer would have. So there's no screen, there's no USB interface, there's no large storage device, especially a permanent storage device like a hard disk. There's no screen, there's no communications other than serial communications with its own peripherals and small sensors. So it is still a computer, but it's a special class of a computer because it is based on what's called a microcontroller, right? So a microcontroller is a device that is specialized to communicate with its environment. So it's got pins on it that allow you to connect them directly to an LED, for example, or directly to a sensor. It's got an analog input, for example. You can connect an analog sensor directly to it and get a number back, which the Raspberry Pi can't do.
No.
Right, so think of a Raspberry Pi as a computer and a miniature version of the computer that you're using right now, and the Arduino as a special class of a computing device, a microcontroller specially designed to communicate with its environment.
So how
and no operating system.
No operating system. So how I explain it to people is the Raspberry Pi has the brains of your cell phone in it, essentially, almost literally, and the Arduino has the brains of, say, your dishwasher or washing machine. So yeah, you can program it, it can do some stuff, but it's certainly not as smart as a Raspberry Pi.
Yeah.
Okay.
Let's take people's questions.
I can't stop.
Tim, right?
Yeah. Let's try. Tim asks, serial communication issue between the Arduino Mega and the UI computer via USB cable. UI sends commands start, stop to Arduino once in a while. Adreno sends info about status back to the UI every 5 seconds. Everything works for a while. However, after a random amount of time, the UI cannot receive info from Arduino anymore, but UI can send stop commands to Arduino. Do you have any ideas of the issue? Is the serial channel from the UI to the Arduino congested? How to clear the congestion without resetting the Arduino board? So I would say that chances are it's not actually the serial communications that are going down or getting congested per se. I reckon it's probably happening at a higher level. So without knowing what your UI is built in.
Yeah, I agree with Marcus. One thing, I did have something similar to that recently with my quadcopter. So I've got a radio telemetry module on it that constantly sends data to my computer, and that data then is interpreted by my mission planner software so that it uses it to know what the drone is doing at any moment in time. But I also noticed that after a while, the communication seems to stop. And I suspect, I'm going to test that if I have enough time today as well. I suspect that the serial port on my computer eventually gets flooded because I am using a virtual machine. So it gets flooded with too much traffic and it just can't keep up with all the traffic that is coming. You'd be surprised how much text traffic a 9600 baud stream produces after a while. Like my Mac starts heating up after that. So one thing that you can try is to reduce the baud rate and see if that communication becomes a bit more reliable.
I was going to say, yes, lowering the baud rate increases the reliability of the channel. But what I would say is increase the baud rate, but lower the amount of data you're sending through.
That is possible, of course.
And just don't spew data out. You know, do sort of like a handshake where you're sending back and forth.
What you need.
A bit of a protocol, get that happening there.
Try those two things.
Also make sure that your operating system isn't trying to hang on to the serial port, because that can also interrupt things between your device and your end application, with having the operating system deciding that it wants to do something with the port.
Yeah, I hope that helps. Let us know how it goes, Tim.
Yeah. Let's keep going.
Steve, can't sue. Me neither.
Yes, it's an important skill, one we've got to learn.
Interesting, I suppose, bit of information in the previous webinar that we did, or not webinar, but web chat that we had live stream. I had one student that wants to use the Adreno to automate a sewing machine, funny enough. So I hope that one day you can just tell your sewing machine, I want XYZ, like a 3D printer, and we'll just do it. So I don't have to do that.
One day.
Okay.
So,
Tim.
In general, can the Adreno be used in a commercial product? Absolutely. Any legal constraint? None whatsoever.
Yes.
The answer. If yes, is the solution, do you purchase a license? No, you don't need to purchase a license. You can be part of the Arduino at Heart program, where if you've got a commercial product, you can choose to pay a license and then get marketed by Arduino themselves and put a little logo that says Arduino at Heart on the product. We did that when we built the MicroView, which is a type of Arduino that we did a Kickstarter on. And on the whole, it's not worth it, if I'm going to be honest.
Of getting, you mean the Arduino at Heart
logo stamp.
I can also add that if I suspect, based on your question, like the Arduino obviously is a trademarked name, you can't just use it. If you're planning to take, say, a genuine Arduino Uno and make it part of your product, so you buy the Arduino Uno, you plug it into the rest of your product, and then you put it in a box and you sell it like that.
Absolutely.
I don't think there's a problem with doing that, but I'm also questioning why you do that. Remember, the only thing that you want is the Mega controller, the microcontroller on it. So having the whole board there is, when each genuine board is $30, like economically it doesn't make sense to do this. It's probably better to just design your own product around the Arduino ecosystem. Like you can use the Arduino software and the libraries and all that is totally open source. It's not a problem. And just have the microcontroller on your product, so not the whole Arduino Uno or other Arduino branded board on it. It's going to be also more economical, and the volume of your product will be smaller. I hope that answers your question.
Yes. So Tim asks, can you please suggest the best interface board or shield for wireless or Bluetooth communication between Arduinos or between Arduino and computer? Well, there's lots of ways you could skin this fish. It depends what you're trying to achieve. So he said computer's the keyword, not mobile phone. If it were a mobile phone, I would be suggesting going down the Bluetooth low energy route, which makes pairing a little bit easier as well and saves you some battery life. From a general wireless standpoint, if it's going to a commercial product, I would recommend a Wi-Fi module like I'll stay away from Bluetooth because Bluetooth stacks on computers in general suck. Especially, I want to say like a Windows ecosystem where the hardware inside the computer is going to be very diverse as opposed to our friends at Apple. If you want to go down the Wi-Fi path, I would suggest like a Wi-Fi module like the CC3000, which is going to be a little bit more solid than what is, I would say, the very, very popular ESP-based modules.
I think the 3000 is kind of a bit old these days.
I am dating myself here. I'd say whatever's in that line.
I should remember that, but because have a look at, if you want to go the Wi-Fi route, then probably the WinC 1500, the Wi-Fi Shield, is a good choice.
Yes, that's true.
The WinC 1500 is a product from the same company that makes the Megas, and it's integrated in a couple of Arduino products. Sorry, I can't remember the models at the moment, but it does come as a shield as well, and it does work with the Arduino Uno. I've used it, and it's solid.
Yeah. So why?
I like the WinC.
So why I was going down the CC path is that it's got a better story when it comes to pairing, doing that initial setup phase. So it can do a thing where it's essentially running two radios at the same time. You can have your app be connected to the Wi-Fi that's in your Wi-Fi network, and then it can also do some crazy pairing packet thing where you can be connected to two Wi-Fi networks at the same time and get it all up and running. I've forgotten the exact way it did it all, but I remember very early on when I was part of Ninja, we looked at doing it with the CC3000 or 2000 or whatever it was back then. So yeah, stay away from the ESPs for commercial application, but for home, by all means, it's great. They're cheap and cheerful, and gosh, I wish we could have gotten Wi-Fi modules that price back then. They're in the low dollars.
Well, it didn't exist.
No, they didn't.
The other option, of course, is Bluetooth, right? Especially if you want point-to-point. Like the Wi-Fi, you require the additional a Wi-Fi hotspot. So there's an additional layer there. And I should also notice that the WinC 1500, especially on the Arduino Uno, is borderline because of memory issues. So if you do use it, you probably want to use it with an Arduino Mega so that you get enough flash and RAM for whatever else you want your gadget to do. But then you can also look at the Bluefruit LE shields and breakouts.
And the Blue Smurf one with the Nordics.
And Nordic chips are good, yeah.
As well, but I tend to stay away from Bluetooth because I am a lazy web developer and I like to do things at that high level.
Yeah. So again, I hope that makes sense. Like Wi-Fi and Bluetooth have specific, not specific, but you can rule one out if you want to build a specific application. So if you want to take, for example, simply connect a peripheral like a keyboard or a keypad, for example, to your computer, then it doesn't make sense to do that with Wi-Fi. But that's more of a low volume in terms of bandwidth requirement and data transfer than Wi-Fi. So you go with Bluetooth or something like that.
Okay, so next question. Any pointers where I can find info on using SIP trunking with an Arduino so that we can make something like an intercom or VoIP phone and call it using an IPPBX? Well, from the get-go, I would say the Arduino itself doesn't have enough power to do that. So it needs something hanging off the side to be able to handle the communications and voice side of things. I think a Raspberry Pi would be your best bet for that one. And there's a lot of like SIP like apps that you can run on the Raspberry Pi. I've had a look at a few of this because we do everything at Little Bird using SIP and VoIP, and there's one command. I've only seen one good command line one. I will have to take a rain check on that, on what it is, but I'm sure you'll be able to find it without too much Googling.
So did you want to make a note to get back to Justin, or
Yeah.
like Justin to get back to you?
I'd like Justin to do Raspberry Pi, SIP, command line. That is the search to look for. And I think that should be enough to do the intercom side of things. And maybe you don't really need the Arduino to do the rest of the features that you might do with an intercom, buttons, a little screen. You could probably do all of that with just the Raspberry Pi.
Yeah, I think you're right.
So yeah, I would, and security as well. So you're not gonna have an easy time doing, encrypting the voice communications and just doing standard security on an Arduino because it doesn't have the power to do the crypto.
Cryptography and to transfer the audio,
Yep.
like voice packets themselves.
Yep.
It's kind of high bandwidth.
So you might be able to get away with it with a what's the ones by PJRC, a Teensy.
Oh, right.
I've seen some
Teensy.
amazing code that Paul has written for audio. So if you're on Little Bird, just look at Teensy. Or pjrc.com.
Sorry.
Yeah. I don't own the littlebird.com domain yet. They only want $1 million. But that's okay. You just search for PJRC and you'll have your answer there. Or an option there as well. Okay, so next one.
Brian.
I'm doing a watering system right now. Awesome.
Yep.
You can certainly have a look at Open watering system?
Yeah,
it's a
an
project.
open source project.
Trying to remember the name.
Brian, is that on your garden, or are you doing maybe a glass house installation that's kind of indoors? But yeah, I have heard of open source. Does watering systems. Okay, yeah, if you like, give us some more details about what you're building.
Yes.
Okay, next is Scott.
As an amateur radio crazy guy, I'm using an STM32F446. These are the questions Maddie loves to get on the phone, by the way, so call her up. As an interface between a Raspberry Pi and an ADF7021 radio in a chip as a digital voice hotspot. Okay, scroll down. Is there a question? And there's no question.
Maybe he's continued further down. No, I
Scott
don't
Evans?
see Scott again.
Well, good for you, Scott. Good statement.
Yeah, I used to be a crazy radio guy.
I would like
years ago.
I want to have a look at the ADF.
Sorry, I just noticed that Brian has got a response. So it's a low water, low power greenhouse. Yeah.
Okay, that's perfect. So yeah, there's a whole bunch of Arduino, I want to say OpenHab projects where you can essentially just lift it straight up. And who has done this in the past? I believe John Croucher, who is on this chat. So John, okay, John's giving us a list, a URL for a Raspberry Pi version of this, which is jcroucher.github.io/pi-water. We'll put a link to it.
Oh, okay. Michelle just told me that there is Open Sprinkler project. I'm just going to post it here for everybody to see. So there is an open source project called Open Sprinkler. So where was Brian's?
That one, yeah, I'll paste it here
to everybody. So Brian, have a look at the thing that I just posted that Michelle discovered, and maybe that's something that could be useful to you.
Yes. My wife is just SMSing me to tell me I'm off screen on the Facebook Live. It's okay. Use the real webinar. Okay, so next one.
Where were we? Oh yeah. So from Anthony, he's asking if there is a serious outdoor moisture sensor that we can recommend.
Cheap ones corrode in a short period of time.
That's a problem, right?
I don't know.
That's
a good question.
So is it a moisture sensor, Anthony, that you would plug into the soil?
So I'm going to say that a cheap one is probably talking about one of the ones that is just a PCB, and they take off a bit of salt, like the one
Yes, exactly.
from SparkFun
Like
and
$6.
DF Robot and all the rest. Yeah, you know what you can use? A nail. A nail would be probably a much better alternative. And some thick gauge wire to using one of the cheap and cheerful moisture sensors. And yeah, that really should be enough.
I'm also looking, well, I'm looking at Bunnings.
Yeah, garden soil.
And they're the kind of sensors that gardeners would use, so they would want them to last for a long time. So what I wonder is if you can go to Bunnings and get, say, a $12 moisture meter like Runman and then hack it. So open it up. The only thing that you need is really the element that goes into the soil. So maybe you can do something like that instead of buying one from SparkFun that corrodes, because I think the material.
It's not just SparkFun. We've got to be fair.
Oh, sure.
to SparkFun.
You know, the hobbyist stuff.
Yeah.
Because I think what's important is the sensor itself, not so much the circuitry in our case.
You can
because
just
you will implement it yourself. So maybe that's just an idea. There's others, like I'm looking here, you can get sensors like that for $359 ex GST. That it's got 2-year extended warranty, and it's something that you would probably use in a lab. Like I think this is high accuracy moisture sensor that an agricultural lab could use, but 2 years warranty. I'm sure it will last that long, but $300.
Yeah, a nail will do what you need to achieve.
Okay. I'm going to just link Bunnings here. So that's one. Next, Andrew.
Oh, this is a great one. Andrew asks, is it worthwhile to combine Arduino with a Raspberry Pi to get the best of both? Or is there a better solution? So this is something we did a long time ago. I founded a company called Ninja Blocks before leaving it. And one of the things that Ninja did is they had a BeagleBone, which is a product similar to the Raspberry Pi, which sort of predates the Raspberry Pi, or at least the Raspberry Pi was not in general availability back then. And we made a shield for this BeagleBone, similar to what you could do with a Arduino, similar to what you could do with a Raspberry Pi that had an Arduino on board. On the bottom we had the BeagleBone or Raspberry Pi, and on the top we had a shield, and it would sit on top, and we had the best of both worlds. And what we found beneficial is that we could take all the Arduino libraries that were out there and immediately use them. So we used a lot of the wireless communications libraries and use those with our system. Also, as Peter mentioned earlier, the Raspberry Pi and a lot of these embedded computers lack the ability to do the analog digital reads. So they can, some of them somewhat output some analog and in a limited fashion. These chips are primarily designed to go inside cell phones, so there's not too much of an application for them to do analog out. Beyond maybe changing the backlight of a screen or the backlight of a keyboard. So they generally don't even have 3 analog outputs, and by combining an Arduino with a Raspberry Pi, you can boom get a whole bunch of analog outputs.
Yeah.
Yep. So yes, it's a great endeavor.
There's many projects where you can combine them. Like I'm thinking of home automation projects. So you can use the Arduino as a node that either senses or actuates something.
Oh, like so, totally separate, is it?
Separate, yeah, separate, but part of the same system. So your Arduino will be there to turn your lights on and off, and to sense the temperature, moisture change, so you can turn the air conditioner on or a fan. But the Arduino would not make any such decisions. It would just react to a central node, which is the Raspberry Pi. So you've got nodes on the Arduino with their sensors and the actuators around your house, and those nodes will send the data, usually wirelessly, for example, to the Raspberry Pi. And on your Raspberry Pi, you can have your code written in Python or some other high-level language. We could say things such as, If the light sensor in room A detects light level below, say 600, then turn lights on. So there's the input from the Arduino. The Raspberry Pi will process that input, say, okay, it is true. Going to send an instruction back to the Arduino in the same room, which will turn on the lights using a relay. So you've got a very simple system like that, and each platform, Arduino and Raspberry Pi, do exactly what they're really designed for. The Arduino will interact with this environment, doesn't have much computational capacity, so it's not going to do anything else. Send the data back to Raspberry Pi. Raspberry Pi full computer will run your complicated product program easily, and will tell the Arduinos around your house what to do.
So the other thing I'd say is the Arduino gives you a bit more flexibility on the voltage side of things.
Yes.
It's going to be a little bit more hardier than the Raspberry Pi, and more forgiving when you connect up things.
That's why I like wireless communications. If you burn your Arduino, it doesn't affect anything else.
No, keep on buying Raspberry Pis. There's a great company called, never mind.
Okay.
So, so Brian is telling us a bit earlier, we're talking about the size of packets and clogging up serial ports, and he said I had to keep packets to 64 bytes to make things work. So thanks for the info on that one. So Peter Brock also comments, if the data is from a sensor, you could do an average and say send every 2 to 3 samples. This would affect latency/lag. Do you really need to be sending data at such high rates? So that's a question to ask when creating systems that are sending from an Arduino to Raspberry Pi. And this is often a good idea to do anyway, because sometimes the data you're getting back is a little bit noisy, and by averaging it out, it's going to be truer to what we're actually experiencing in the real world. So the question is there an alternative to the Freetronics Ether Duet? I can't think of one off the top of my head.
So that's an Arduino Duo clone with Ethernet on it. Probably an Arduino Mega or Arduino Duo with
a shield, which is not that. I know you want the finished product. I don't have a direct answer for that one. I'll need to think about that one, which actually brings us to another question we had that came in via the email. What do you do when your project requires too many pins on an Arduino? When you add devices, you eventually run out of pins. Can you stack shields and have devices share pins? So what is a shield? A shield is a daughter board for an Arduino that you stack on top, and it gives you some added functionality to your Arduino. And many Arduino shields are designed so that you continue stacking the shields up, and so that unused pins can be passed through to the next shield. So Peter's wandering off, so I'll give you the brief answer to this. Well, there's one way that you can add more pins to your Arduino is by adding a shift register, and you give up a few pins and then get a whole bunch more. That's one option. In terms of stacking shields that have shared pins, it depends on what you're doing on those shared pins. If you're just turning something on and off, maybe it doesn't matter. It depends on the schematics, and how the different shields are designed. Your thoughts?
Yeah, like for example, the Arduino does have I2C, which allows you dozens, practically like on paper, depending on the version of addressing, probably over 100 devices can be connected on the same bus. So one thing that I do is I try to put as many sensors usually or other devices on the bus, and that way no matter how many of those devices I have, I still have the same single data pin and power to worry about, so I don't take up multiple pins on the shield. But if I want to do things like LEDs, like if I want to control 20 LEDs and my Arduino only has, I think, 8 digital pins, then we go for a port expander or a shift register. So it all depends. There are ways to go about doing that. If you want to have
Charlie plexing.
Sorry?
Charlie plexing.
Yeah,
if you want to
multiplexing.
Yeah,
another thing you can do is if you just can't fit enough things on your, like I've got an example here, something I'm working on. So I've got my screen, I've got a prototyping shield below it, I've got an Ethernet shield, and the Arduino will go below that. It is starting to get a bit crowded. So what I did was to design a custom PCB to basically combine whatever I put on my prototyping shield and the screen on top of it, and combine it all in a single shield. And that basically combines these two into one thing. I still need the Ethernet shield. So the answer is, it really all depends. Try to build on the Arduino's strengths, and that means its communication capabilities, and then simple external blocks like shift registers and port expanders help you overcome pin shortage problems.
Good. So is there a next question from John? Is there an Arduino style board with a bootloader which can execute code from an external storage device like an SD or similar? Oh, I believe I saw a project that did this many years ago, but I
must say I don't know.
Not off the top of my head.
Yeah.
It was on Hacker News. Oh, not Hacker News, Hackaday.
John, this is something that requires research, so I can't give you an answer.
And John is part of the Little Bird fold, so maybe this is meant to be a lowball question that I missed.
It's a very good question.
That's a good question.
Thank you.
I don't know. Actually, we have done this previously using Wi-Fi modules, where we would pull a hex file down from the web and essentially use the Wi-Fi module to flash the Arduino. So this is certainly doable. I have just not done it from an SD card or storage device. So I think the idea is maybe going back to a factory firmware, factory fresh firmware state. Yeah, it certainly is achievable, but not something that I have done.
I imagine that this is possible, and what you get is a sketch that forces the Arduino to go into and start fetching instructions from this external storage.
Yep.
Put it in flash and then restart itself.
Yep.
I think it's possible, but I don't have any specifics.
Totally doable. So you need to reset the.
Itself.
You need to toggle the reset pin on the Arduino on the AT
one
Mega.
Of the digital pins to reset itself.
And then you need to be spewing the hex file through the serial. It has been done before. We actually also did it in Ninja Land when we wanted to reflash the Arduino remotely that was sitting on the little Linux board. We would toggle the pin and give it the new hex file remotely from the other side of the world.
Because that's a way, I'm just thinking like that external device could be like a Bluetooth connection to your computer, so that way you can update the firmware on your gadget without connecting it via USB. So.
Yep, certainly doable. I have not done it any time recently. Okay, so I have a grandson that would like to learn electronics and coding. I've bought an Arduino starter kit with various components. What is the best resource we should look up to get some projects to get started? And that's from Terry. Well, you might have an opinion on this, Peter.
I do. So I'd like to know how old is your grandson, Terry, because that does affect, for example, it does have an effect on this. So for example, if your grandson is fairly young and not able to read proficiently yet, then you'd be looking at a particular type of projects and technologies, especially the programming level, and in particular block type languages or block graphical type languages. So through those means, your grandson can start becoming familiar with programming concepts and build up from various skills from that point onwards. And there's a lot of technologies that can do that, open source, all of them pretty much. Like you can have a little robot that your grandson can put together. That's a wheeled robot, and then program that robot using block-based language. So kids as young as 7 years old,
younger,
and even younger, can get started that way. Now, if your grandson, however, is able to read, but but never programmed in the past, he can still consider a block-based language to begin with. It seems to be like it's colorful,
Visual
and
programming.
it's playful, and you can still use the same robots. And your grandson, in that case, will progress much faster than a younger kid, and eventually will come into a traditional text-based language.
So an MBOT is Arduino-based.
An MBOT is an example of that. So I'm not sure if you are familiar with the MBOT, Terry. Maybe.
Yeah, just if you search for MBOT on Littlebird, you'll find it there.
So I do have a course on the MBOT which teachers use in their classes, and we also have a book.
We have a book, mbot-book.com.
Written a book. And teachers use that book in the classrooms. Apart from that, if your grandson is maybe 14 years old and older, then he's more dexterous with his hands, and he can put things like this together, for example, which is a big problem for smaller kids. If you can put things in the pins, handle small items like resistors, then I think, in my opinion, best thing would be to go straight for an Arduino. Get a kit which contains basic components like resistors, transistors, small sensors, and then start playing around with those things. And I don't want to self-promote, but I do have a course on this as well, because one of the things that, as I said, I'm an educator more than I am a maker. I try to build courses that STEM students and STEM teachers will be able to use in the classrooms or in their homes. I've got 2 kids that I'm homeschooling, and they are now into all this technology as well. I'm actually using them as my guinea pigs. So Terry said he's 12 years.
Yeah, 12 years old.
Yeah. And
Michelle has actually just come back to us with a few answers as well.
Yeah.
So to wrap up, Terry, I would also recommend having a look at the Crack the Code unit of work from the New South Wales Department of Education, which has some projects in there with cheap and cheerful Arduino gear. The other thing I'd recommend having a look at is the Arduino Advent Calendar Kit, which Maddie put together. It's got a whole bunch of little projects and projects and sensors and actuators and tutorials on how to hook everything up. So that's a good one. So jumping back, Michelle recommends for a waterproof temperature and humidity sensor. There's a mesh protected weatherproof sensor, and we're going to put the link up there.
Was this just to match it?
This was Anthony Watts from memory. Yep, there we go. Is there a serious outdoor monitor?
Sorry.
That one. Yep.
Let's put it here, then so match it with that.
Yep, send to all.
And then Michelle found.
Is there similar to the Freetronics Ether Duo? Well, that would be the Arduino Ethernet, of course. I'd totally forgotten about that one. So that's another option.
This one.
For you.
There you go. And she's got gravity soil sensor. She's found more sensors for Anthony, is it?
Yeah, so probably the gravity one I wouldn't trust. That would fall into the similar category as one of those cheap and cheerful ones. But give it a go.
Okay. All right.
It's by definition cheap and cheerful.
Awesome. Next. Tim is commenting about Scratch. Okay, the best for small kids.
How do you spell MBOT? Sorry. Oh, there's a question there. Scratch is the best for kids to start programming, or Lego WeDo is the best to build a robot on with block programming? So WeDo is very expensive for what it is. I would tend to go down the MBOT route. They've also brought so this is like the general category of constructive robots where you get to build the robot and create solutions to problems. There's a step up from the MBOT called the MBOT Ranger that we have, and that allows you to build more robots that are in different forms, put it that way. So,
I should also say about, like, Lego is obviously amazing, right? I really look up to them, and especially how they build the educational materials for me. It's a huge example. But as an educator, what I don't like about Lego is that it's all a proprietary system.
Yes.
Right, and looking at the language, for example, the graphical language is really nice, colorful, but it's the only product that uses that particular block type language. When you look at the MBOT, and there's many other examples like that that use a more standardized block-based language developed by MIT many years ago, where which is also open source, and a lot of products also share it. What that means is that your child will be able to jump from one Blockly type product to a completely different Blockly type product, and they will still be able to find their way around the programming interface. Where with Mindstorms, Widow, etc., because of their proprietary languages, you can't really transfer at least those specific skills. The programming concepts are still the same. You still learn programming, it's fine. It's just you can't transfer the exact same skills from one product to the
We
other.
sat in a lecture on the Mindstorms programming language, and what my memory of that was, or concern was, that some of the blocks, there were multiple things happening in the box that were just magic. Whereas if you're doing something like Scratch, which is free to download from MIT, it very much mirrors what you would be typing or doing in real programming. So it had
That's another problem. Yeah,
it's like magic, just happens.
But that you mean that the block in the Widow, for example, has got too much obscured functionality in it. Instead of having just one block does one thing, there's examples in Widow where one block does like 10 things, and you just can't break it out. If you're the child learning, you can't break it down into, say, one thing intuitively, which you could in a C-like programming language where one instruction does one thing.
So bit of magic going on.
Don't like magic things.
Yes. Let's see. Please email me your course name. We will email you the course. We've done that one. We're getting some duplication here. I think we
check to see if Michelle has something that we should share with people.
So
just scroll down. We've seen that.
So Michelle is also prompting us to have a look at some of the new Sunfounder gear that we have on Little Bird, which is an Sunfounder Ultimate Sensor Kit. And one of those in there is a raindrop sensor in the kit. So
I'll just put it in the general discussion for the entire audience.
That's a good idea. We should be doing that.
Yeah.
And of course, we've got
Michelle, if you like, switch from private to
public.
Just to send you messages to everybody.
Yes. Okay. So we've got some more messages in on the email before we have to wrap up. Let's have a look.
This is a good one, I think.
So I want to bring Arduino into my classroom. What do I need? Do I need to make any changes to the Arduino IDE? Well, do you have the Arduino IDE on your computer, Peter?
Yes.
Do you ever use it?
All the time, constantly.
Do you want to open it up and have a look at it? Because we have the technology to do this.
I'm just thinking whether the question is, many classrooms, because I'll bring it up while we're talking, because it takes a while to load my Arduino IDE. It's very loaded up. Many classrooms in state schools, for example, because of IT constraints or the IT infrastructure, the way it works, tends to be locked down in terms of functionality.
Yep.
So a lot of people are having trouble actually installing the Arduino IDE. And once you install it, then you have trouble connecting devices to it, like the USB port may be locked up.
Yep. So
maybe that's what this question is about.
So, okay, I've got a bit of experience with that one. So Arduino is generally part of most of the catalogs where people can download the Arduino via the internal IT systems of the various school networks. So that is doable. But there's multiple versions of Arduino. And one of the versions of Arduino is designed for environments that are locked down, where you cannot necessarily install software with an installer. And so if you go to arduino.cc's,
Close to that now.
yep. So,
Let's show you my screen.
yeah, so go to sharing. Oh,
This one here.
yep. And
Oh no, I wonder what is it that our friends are looking at.
so, oh no, we're seeing this.
Oh,
the
okay,
screen.
okay. You can see all
Brilliant.
my stuff.
Maybe just pull that.
This is
into
not
the next.
visible. It's not visible
Okay.
to our audience.
Magic.
All right. So let's have a look at this. So you go to software. Can we still?
Yeah, maybe it's just gonna catch up. Or have we broken the?
Maybe I should not have done that.
No, it was working.
Oh, sorry. Okay, let's go back. All right. So if we go to software downloads.
Can we zoom in? Hold down Control and scroll for me forward. Maybe. Oh, you don't have that turned on. Oh yeah, all that. Oh,
that's a bit too much.
Okay.
So we go into software downloads.
Of course, there's the online IDE now.
There is the online IDE, but I don't like it because then there's also restrictions on which website you can access, and
you probably have to use Chrome as well.
With online, often what I find is that there's a big lag between when you try to compile something and then upload to your Arduino. And imagine a class of 20 kids having internet problems.
Yeah.
That's why I much rather prefer to have downloaded the Arduino IDE on my computer. So there's fewer things that go wrong.
Yep.
So which one is Marcus?
So actually on the right hand side here, we've got two versions. We've got one that's Windows installer for Windows XP and up. So that's all the way up to Windows 10.
Right.
And then there's the Windows zip file for non-admin install, which allows you to do things and you're essentially just running the application from there instead of installing it.
So this is what you need then?
Yep, that's what you need. Or you guys could just all switch to Mac and live in a wonderful, beautiful world.
If you work for a Department of Education school, you pretty much have to use the Windows zip file. It's not a part of the e-textiles platform that the DOE or whatever it's called now uses. It's not really optional unless you have to get your administrators to do it, and apparently that's not the simplest process in the world.
So there is a bit of a challenge there, but once you get it to work, is it like relatively bulletproof, especially any problems with USB ports?
I don't work for a public school, so I don't have the issue, but I know people who do, and I think once they got it installed, everything tended to work okay.
So a lot of the issues that I've seen schools face is the use of the USB to serial chip. So if they're using a chip and chip for Arduino that doesn't have a real FTDI or doesn't have the Atmel serial to USB conversion, say that you'd find in a 32U2 and 32U4 that's built into the chip, you will have to install additional drivers to get it to work.
And the Mac has the same problem.
The Mac definitely has the same problem as well.
Yeah, so that's one reason why schools buy genuine.
Yep.
Because they don't have driver issues.
Just buy the little bird Arduino. Like seriously, like it's cheap and cheerful, but has the right compatibility there.
Yeah.
There's another question that we got in via the email. Is, do we have to pay for the Arduino software? So go to download the software and have a look at this. What do you call this? Dark design? No. Go back to where you are.
Oh, sorry.
Yep. So, and click on click on the
one of
Windows.
those download. Yeah. Okay.
It's going to throw up this big page with a big button, contribute and download. You don't have to do it. You can also just download. If you want to feel good about yourself, you can.
I do that once a year.
Do we not have a lot of money? I don't feel as burdened to do that. I would rather give it to engineers without borders. Those are the ones to do.
That as well.
Oh,
we should post that.
Yeah, they are really good.
So engineers without borders?
Yes. Yeah, Arduino is getting money from Microsoft, from Intel, from all the big guys.
Okay, that's.
I think they'll do okay.
Yeah, good cause.
But EWB, Engineers Without Borders Australia.
Thank you. Yeah, I didn't know about this.
Yeah. Also, if you're slightly technical, it's worth, I'm sure, getting involved and seeing what you can do to volunteer.
Engineering changes the world.
Yes.
Okay, let's move on because
So there's
I'm mindful of time now.
There's a second part to that question. Do I need to make any changes to the Arduino IDE? And I think that's a brilliant question. Yes. If I were teaching with the Arduino IDE, what would I do? I'd instantly increase the font size because I'm projecting to the other side of the room typically, and I would turn on line numbers. So you've already got line numbers turned on. I can see.
Okay, let's wait for the video to catch up, and then we'll show how to do that.
Yeah. So, okay, there we go.
All right.
So on the left-hand side, we've got those line numbers, which are showing us what the number of the line we're on. But how do we turn that on? Well, we go to Adreno.
Let's fix the font size first.
Preferences.
Make it 24.
Yeah.
Imagine your students now. Typically, your students don't have much. Or maybe some would do like poor insight. Typically, kids have got a better eyesight. But it depends on how you're projecting onto the screen. But always better to have a large font size.
Yep.
So that's how you change it. So you go to preferences, and then this window will come up. Font size. So that's one thing.
I'm actually turn on. Well, yep. So yep, go on to display line numbers.
And the other bit of configuration is display the line numbers so that you can make reference of the line number as you are describing your sketch.
The other thing I would do is also turn on code folding.
Yeah.
So we'll
all right.
click
So
OK.
go to program.
And of course our text is a lot bigger. And with code folding, what we can do is we can sort of fold up little sections of our code, be it our functions or, yeah, that's pretty much it, functions or classes. And you can have more on the screen. So this is good if you've got a function hiding down the bottom and you want to talk about how it relates to something at the top and vice versa, and especially so if you're pumping up the font size and don't have a lot of room on the screen.
Yeah, it's a good way to summarize your code and see what you've got in terms of functions. You can also fold inside a loop, right, or inside a function. So you can see I've got an if statement here, and I can just fold that down. So there's my if, there's my else if, and other else. So now this shows you exactly what you need to know in order to decide whether your logic here is correct. And once you're happy that your logic is correct with these if statements, then you can drill inside and deal with the functionality in each else if statement.
Which version of Arduino did this come in? Because I have to say I use an external editor.
I'm using 1.8.5.
1.8.5. I wonder when that came.
It's been a while. I remember that. It's a while ago, yeah.
Okay.
So just these two things I think would make a big difference in your classroom.
Okay, so we've got a couple of questions there. What is the easiest way to play a digital sound file? I was planning on using a DAC port on the GUI. Wow.
Go back to us.
Yeah, Arduino, what do you call it? Playing audio on a Arduino is a pain in the neck because the Adreno doesn't have the grunt to be able to play the encoded file typically. So
Arduino Duo does because it's got 2 high definition analog outs. Real analog out, not PWM.
Yeah,
so the Arduino Duo.
I give you a WAV file or a MP3. Are you going to be able to play that with the Arduino Duo?
An MP3, probably not. No. But a WAV, I think a WAV, yeah.
I have to say I have not tried this. Again, being a lazy web developer. But if I were to do this, I would be using something like an MP3 trigger or that's from a product from SparkFun, a shield that you stick on top of the Arduino. You load your MP3s or WAV files up. They've got a WAV trigger as well. You load that up on an SD card, and then you can get your Arduino to play that.
Do you have that?
I'm sure we do, but you're looking at the you're looking at the staging site, my friend.
Oh, right, okay.
Littlebirdelectronics.com. So yeah, just go to Littlebird and search for WAV trigger or MP3 trigger. MP3 trigger. And there you go. There's a whole bunch of different things. And Adafruit have their versions as well in different form factors. So yep, anything from SparkFun, Adafruit, Pololu, I would be comfortable recommending. Okay, going down, Peter Brock. My point of view of graphical programming like Blockly and Scratch allows users to understand the basics without getting stuck on the exact syntax and grammars. Yep,
yeah,
absolutely.
Absolutely, yeah. One interesting thing to also add here is that I agree. Like Blockly is great way to get started. Both my kids have got dyslexia, so for them it's not easy to read. Like it takes a lot of time to read the word void. Not so much now, but say a year ago it was a big challenge. Void. Okay, it takes a minute to read void, another minute to read loop. So, no problem with Blockly though. They were able to understand the different shapes and
Sure, the colors
put them together. The
well.
colors were helping. So yeah, so even for kids with special learning needs, Blockly is great, and you can get kids started with programming before they can read. Get all these concepts in the head, and very quickly they themselves start looking into what's the next thing, because Blockly now is a bit, takes a lot of space to do something simple. Even my son, who's now 10, started with Blockly. He's now getting more comfortable with Python.
Yep.
Not Ruby.
Nobody's perfect.
Because we were playing with Microbit. So Microbit makes it amazingly easy to switch from Blockly to Python. Just one button and shows you what the relation is between the graphical code and the Python
or
code.
Even JavaScript with
which is another nice thing that Blockly does well, where Lego doesn't. One block in Blockly is it tends to be one instruction in Python, so you can see the correspondence really quickly.
So what is Python? Python is an interpreted programming language.
It's a modern language that professional programmers use to build incredible things, right? Things that we use every day, including like Google was built on Python. Okay, the search engine was built on Python. You can use Python to write your modifications for Minecraft, for example. So it's a serious tool. Emily.
Question for Emily. Question for Emily. Do you find that the practical aspects of e-textiles are engaging and creating excitement with students in the classroom? As a parent and beginner with e-textiles, how can I introduce this medium to my children?
Yes, I do think it's engaging. I just dropped out now. No. So yes, I do think it's engaging with kids. I think it's cool for them to actually get to see, like, especially when they're doing the coding side of things, to actually see things work. I think it's especially engaging for kids who maybe aren't traditionally into textiles, to see a different application for it rather than just, using a sewing machine and doing all these other things. I think if you want to get your kid into it, a lot of it's probably about, like, I think the way is using stuff online, especially if they're not doing it at school yet. Using projects and things can be found online, kind of starting with basic things and then seeing what they can use those skills to do afterwards. Starting with something like the lily pad or the flora or something is usually pretty good.
Okay, awesome. Thank you.
So it is very engaging.
Well, what it's doing is it's taking computing outside of just yet another square rectangle screen and bringing it
Emily,
into
I've got a question for you. Do you need to know how to sew? Sew.
Like a basic running stitch, yes, but that's pretty simple. You don't necessarily need to know how to use a sewing machine or anything to pick up some basic textile stuff. I mean, it probably helps to have some basic sewing skills and things, but it's something that's the skills that I've used with e-textile so far don't necessarily need to have, they're not exactly complex sewing skills, it's basic.
So what you need to be able to learn the basics of is the ability to attach a device. It could be a sensor, for example, like a tiny thing onto your clothing. That'd be one typical skill that you need to learn. And then to pass conductive threads to your clothing to connect things around your clothing. Is that right?
Yeah. So tying a knot with conductive thread, making it secure, making it a tight connection to the board or the sensor, and then basic running stitch to run it through the fabric.
Any other tools that you would suggest people use, like other than sewing things on your clothing? I'm just thinking of
conductive copper tape, conductive Velcro.
Tape, like, what are the other typical tools that you can have in your kit?
Conductive
fabric.
Yeah, conductive fabric is another really cool one.
Like I'm thinking Velcro, for example, like you can attach a piece of Velcro on your clothing and on it a device, like a battery, for example, so they can easily remove it to charge it, or just other options like that.
Yeah, that's definitely a good thing. Things like Velcro that you can actually remove things easily. I know one of the things I've been playing with lately is conductive felting. So you get your conductive fiber and you needle felt it into fabric, and then it's an extra way that you can do things as well.
Can we maybe ask our audience to send us a thumbs up or thumbs down or a comment if you'd like us to set up a special webinar for Emily to show us some of those things, maybe about half an hour or so?
Yeah, that's a great idea.
So if this is interesting to our audience,
so just
organize that.
A couple more comments actually coming in from the Facebook. Paul Wilson asks, can you show us the cover of your book again? They can't see it.
Yes.
So the book's name is Maker Education Revolution, and it search for Peter Damaris online, and you will be able to find it pretty quickly.
You can get it from Little Bird.
Oh, from Little Bird. Oh,
yeah.
Yeah. We have copies at the Little Bird warehouse as well. So get that with your next order. Yep. Charlie Nancaro also says that using the Arduino IDE in the classroom, make sure all computers are fully loaded up and installed, including serial drivers, libraries for Arduino, etc. Make it available on any self-serve software systems at the schools for easy installation. Test and test again, and let the kids loose on it. I'm being asked by Charlie, where else is this being broadcast? This is being broadcast on a piece of webinar software called GoToWebinar. If you look down on the Facebook page, you'll see a link to that that webinar system. We've got a few more questions on the webinar side of things.
Peter Brook points out something interesting.
So the schools in New South Wales Department of Education can remotely install Arduino using the UDM. Talk to your computer coordinator. My only problem was Arduino clothes that need separate drivers. So this is that issue again where some cheap and cheerful Chinese Arduinos have the serial to USB converter that requires different drivers. So let's have a look at the next one. I install the Windows installer with no problems, except I have to manually install libraries via zip. Cannot use online manual manager libraries. Function DOE score.
That's from Andrew O'Brien. So Andrew, does it mean that there's some internet blockage, perhaps a firewall that prevents you?
Yeah, what I've seen in the past is if you go to the libraries, manage library section of Arduino,
let's demonstrate, right?
Break out to the web and pull down a library.
Let me show that.
I think under the hood that would depend where the library is getting hosted as well. So
network.
Right.
Right.
So you have to set the proxy.
So if there is a proxy in your network, then if you have the credentials to go past the proxy, you can send them here. So yeah, this may be the issue in your case.
Like, to be honest, if I were a teacher, I would not try to get around the proxy side of things, because well, you essentially have to put in your credentials or get the students to enter in their credentials into there. And I think the proxies that are used by the department are a little bit more sophisticated than what Arduino would support if we're in 2018. But I would just include the libraries within the little bundle of your code so that you just have them sitting next to your sketch.
Because what you can do is you can pre-download all your libraries and then simply copy them in your Arduino folder, which mine documents.
Yeah, you had it there.
Right there. This is it, right here.
Arduino and then libraries.
Just paste them in here, and if your IT department gives you the capability to do that, you can do that automatically. Okay, the IT department can do a script that will just send all of these libraries automatically to the same place on all machines. So may that actually be easier than dealing with a proxy.
I wouldn't bother with the proxy, to be honest. It's just going to be but if you can get it working, great, give it a go. But I would skip that one. So not the only coder who can't sew, so a few of those people have popped up. Steve is telling us he's just interested in playing a WAV file, so yep, get the WAV trigger, not the MP3 trigger.
Yeah.
And Belinda Watson would like to do a e-textile webinar, so that's
Yeah, I've got at least one.
pretty good.
You know how to do it.
Very good. Sorry, Emily.
Get ready for this.
Better up. So, do we have any other questions from the email that I feel bad not answering?
We still have maybe a couple of minutes. So
Okay.
actually we are over.
We're over time.
Okay, let's do another couple of minutes. Let's pick.
What do the different buttons of the Arduino IDE mean? I had a few people ask me that recently.
We'll point you to a lecture.
Yeah, actually, there's a.
We'll point you to one of my lectures where I go through the whole Arduino IDE and it explains in detail every little item there, including the buttons. Okay, I'll make a note of that so I don't forget. I'll pick another one. Right?
Yeah, no worries. So what is Arduino? We've done that. What sensors can I connect to an Arduino? Well, a lot of different sensors. Yeah, again, it comes down to what can you not connect, and I would say in the not connecting side of things, it would be generally cameras or wanting to save an image from a camera. You can connect some cameras to an Arduino, so the JCU cam is
still cameras, right? No video.
No, this is a video camera. The CMU cam, Carnegie Mellon University made a camera that essentially has a little arm chip on the back of it that sits on the Arduino like a shield. Yeah, you got it here, CMU cam, so CMU cam, called the Pixie. And I believe under the hood it's running like some sort of computer vision, like Open CV under the hood.
So what's the effect of this running through your Arduino?
So you can make it look out for, say, a bright colored object like a ball, and then
oh, really?
And then it will send to your Arduino via serial the X and Y of where that object is. So it was a Kickstarter.
Check it out, because it's got some pretty high features that I thought the Arduino couldn't possibly do, right? But still, I see here things such as it learns to detect objects that you teach it. Whoa, this is an AI now. And you can connect it to the Arduino. I suppose there's got to be some functionality there that once object is detected, it tells the Arduino that it has, and that the Arduino can do something like start an alarm, right? Or unlock a door. This could be a security system. Interesting.
Yeah, I think, to be honest, your mileage may vary on this one. I'm just crossing my I's and dotting my T's, so to speak. And so, yes, generally speaking, you don't add cameras to Arduinos, but this is one that will. It's the exception to the rule.
This is.
It is really a
you actually connect the Arduino to this, the other way around.
Yeah.
Like it's got serious functionality and capability here. It's a computer. It's an embedded computer with computer vision sensor on it. It's got a propeller chip, like a CMOS camera on it, and there's some amazing things that it can do when it comes to visual work. So
yeah, the short answer is yes, you can pretty much connect any sensor to an Arduino as long as the thing that's getting connected to the Arduino doesn't require processing on the Arduino, because tiny little computer. Any other questions from the email list? How do you have multiple timers with an Arduino? We've got some code that link to. We'll just link to the gist there. Maybe stick it in the chat. I think that's
this whole thing.
Oh no. We will link to that for people who want that.
Yeah, so the Arduino has, I think, 3 timers. The Arduino Uno, like the Mega 328P. Is it the hardware that you use to do, for example, PWM to simulate analog output, or to when say delay 5000, for example, that's one of the instructions that are very useful. That instruction is making use of one of the Arduino's timers and so on. Okay.
Well, I think we might wrap it up now,
Yes.
given we're well over time.
Yeah.
Let us know if you'd like us to do this again, because this is our first crack at live streaming, well, with GoToWebinar anyway, so I'd love your feedback. Let us know what we did wrong, and let us know what we did right, and we'll try to improve next time.
And also for next time, I'd be very interested to know what kind of topics you'd like us to cover, whether you'd like to do, for example, one exactly like today, where you can either submit your questions live or submit them prior, so we can do a little bit of preparation. And another thing that we'd be very interested to see if you guys are interested in participating live with us. So instead of typing in your questions, you can come on your camera, video, audio, and tell us about your question instead of typing it in.
We had the option to do this, and there's two types of streaming we can do. There's one where this is accessible via web browser without installing any software, and I chose that one to reduce the level of friction with people getting onto the system.
But we can try different technologies as well to see which one actually seems to fit best with our community. Steve Bolter also wants to do an e-textiles thing. Okay. And Andrew O'Brien, great. And Scott Evans, I think you and us.
The other one was using that. Good webinar. And NTLM proxy stops. It might be that. So that's a comment on using proxies with Arduino. Might not be able to get out on the net and install the library. Awesome. Well,
Marcus, are you going to put this recording somewhere?
We'll stick it somewhere for certain. We'll link to it.
Okay. We'll let you know where the recording is if you'd like to go back and for reference. It will be available. So thank you very much. Happy Arduino Day, everyone.
Yes, happy Arduino Day.
Go and make something. It's also Mother's Day tomorrow, so I should make something.
That's a good point. I got to go do the Mother's
grandmother,
Day.
wife.
Yes.
So until next time, enjoy.
Thank you. See you later. Bye.
Now, how do we turn this thing off?
How do we turn the thing off? Okay. Bye-bye.
Where's the button?
Finish. There we go.
Yeah.
Ending live video.
Did you stop it? Are you sure?
I'm finished there. Your live video has...
It's being recorded.
Post.
That's what GoToMeeting doesn't do very well. On Zoom, there's a big stop button, stop recording.
Oh, yeah, I would say that is meant to be a
That's
button.
recording.
Yeah, click that.